for which x is x squared minus 5x plus 6 greater than or equal to 0. I think an easier question would be to consider for which x is x squared minus 5x plus 6 equal to 0. As I said greater than or equal to. So equal to sounds nicer. I think we know how to solve equations now. And this seems like a good way to proceed. So let's find x. In this case, well, there are two ways you could proceed. And the first way is by using the quadratic formula. And the other way is by noticing that this has a coefficient of 1. So if this has a coefficient of 1, then you can factor it as x plus, let's say a, and let's say x plus b. And you would know that minus 5 is going to be the sum, and 6 is going to be the product. So do you know any two numbers for which this is true? Well, I know two numbers which are minus 3 and minus 2. So I can write x minus 3 and x minus 2. Well, I don't need the implication symbol. I can just write it as it is. So this trick only works for when the coefficient is equal to 1. And now we have the roots. So x minus 3, x minus 2 is equal to 0. Sure. What's next? Let's take a look. At the behavior of the function. So let's say this is 0. Say this is our first root. This is a root. X is equal to 2 is a root. And x is equal to 3 is another root. Now let's see what happens with the function before. So, in the middle, and after. So these are different phases. This is important to notice. And what we're doing here is called inspection. So we're studying the behavior of the function. So let's choose any number that's less than 2. Well, we already have one that's nice enough, it's 0. Well, how is 0? So what is, if I put in 0 here and put in 0 there, what do I get? I get minus 3 times minus 2, which is 6. So I get a positive number. So the function is positive on this red area on the left. Good. Now let me inspect with a number between 2 and 3. Maybe I'll choose 2.5. Sure. Well, 2.5 minus 3 is a negative number, and 2.5 minus 2 is a positive number. So the result will actually be negative. I'm not interested in the number itself. I'm just interested in the sign. And indeed, the function changes its sign between 2 and 3, because one of them is negative and one of them is positive. And well, you probably guessed that already. The last one will be positive, because if it's greater than 3, then it's greater than 2, and both of them are positive. The numbers are just numbers to test, but you don't really need the numbers. Okay, so now we know how the function acts. And that's already very close to finding the solution. Well, in this case, what would we write down? We would write down that x is in, well, it's in all of this red area. So this red area goes until minus infinity, but it's not included. So it goes before every finite number is included, so, except every finite number is included, no matter how big it is. That's what it means to take all the numbers until infinity, but you don't include infinity. And then you go all the way to 2. Or on the right, on the complete right, you could also go from 3 all the way to infinity. So you take every finite number, every number that is finite all the way, you take it with you. But then you're probably wondering why I still haven't placed anything here or there. And that's because I need to be careful. And notice that here we have a greater than, sure. All the numbers that are greater than it, you just choose this to be open. This is open. An open interval does not include the endpoint. So or for example, does not include 2. But here actually what we have is also the equal. So we said greater than or equal to. So since we have the equal to, we would like to include 2 and 3. Because at 2, the function, well, if you call this a function, then it is 0 at 3 and 2. 2 and 3 are the roots of this function. And so they are included since we are looking at the values that also make the function be equal to 0.